Welcome to True Projects. In this video, we are going to explain about Phase 2 BMI. Introduction. In the Phase 2 BMI project, facial feature analysis is used to estimate body mass index BMI using convolutional neural network CNN. The method gathers face features from input photos and then uses a trained CNN model and facial detection techniques to estimate BMI. Creating and loading BMI and facial detection models, uploading photographs, and running the BMI detection algorithm are all included in the project's components. This groundbreaking program recommends customized insurance plans that are in line with the expected BMI in addition to accurate BMI assessment based on face features. The project adds to customize the insurance solution and healthcare accessibility by fusing cutting-edge technology with healthcare knowledge. Objective. The project uses face feature analysis to predict body mass index BMI using convolutional neural networks CNN. The CNN extracts face characteristics from picture input and predicts BMI, which influences suggested insurance coverage. Modules include image uploading, running the face BMI identification algorithm, and loading BMI and face detection models. This novel method uses computer vision to offer a quick and non-invasive way to calculate BMI from facial expressions. The project promotes health awareness, emphasizes the significance of technology in personalized insurance, and demonstrates the potential of AI in alerting the healthcare and financial sectors. It does this by mixing machine learning with insurance assessment. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirements. In software requirements, we have Python IDLE with 3.7 version. Methodology. To implement this project, we have designed the following modules. The first module is generate and load BMI and face detection models. In this module, the project involves loading two types of models, face detection model and BMI detection model. Face detection model. This utilizes the OpenCV library to load a pre-trained model designed for detecting human faces within images. It's used to locate and isolate faces from uploaded images or webcam frames. BMI detection model or convolutional neural network CNN model is loaded. This CNN is trained to predict body mass index BMI values based on facial expressions extracted from images. Second module is train XGBoost regression. Here, an XGBoost regression model is trained. XGBoost is a gradient boosting algorithm used for regression tasks. This model might be trained to predict calorie burn based on various features, potentially including factors like age, BMI, and activity level. Third module is predict burnt calorie. This module takes input data, possibly including features like age, BMI, and activity level, and uses the trained XGBoost regression model to predict the number of calories burned by an individual. Fourth module is predict age and BMI from image. Given an input image, this module processes it through the CNN model loaded in the first step. The model analyzes the facial expressions in the image and predicts both the individual's age and BMI. Fifth module is predict age and BMI from webcam. Similar to the previous model, this module captures real-time video frames from a webcam. The CNN model predicts the age and BMI of the person in the webcam, feed by analyzing the facial expressions in each frame. Execution. For the execution of the project, we need to open the code folder. This is the code folder. This is the dataset folder. To implement this project, we have used calories and exercise dataset. Importing calories contains the information of user ID and calories. Importing exercise contains the information of user ID, gender, age, height, weight, duration, heart rate, body temperature. This is the images folder in which we have the test images which we have used during the execution of the project. This is the model folder. This folder contains pixel files which can be loaded into the project code during runtime to utilize the train models. and these are the Python files which are used in the main code for the execution of the project. This is run.bat file. Instead of executing the project in the command line interface, we created Windows bat file to execute the project. Double click on run.bat file. This is the graphical user interface which we have created using Tkinter library in Python. Using this GUI, we will interact with the project. Click on generate and load BMI and age prediction models to load the model. So here we can see that the models are loaded. Now click on train XGBoost regression to train XGBoost on calorie burn dataset. So here we can see that we got the mean square error of XGBoost. Mean square error is the difference between actual and predicted values. So the lower the MSE, the better is the algorithm. And here we can see observed burnt calorie and predicted burnt calorie. We can see both values are too close, and below is the graph. So this is the XGBoost regression calorie prediction burnt calorie prediction graph. So the x-axis represents number of test records and the y-axis represents the burnt calorie prediction. Red line represents original test calorie values and green line represents predicted burnt values. And we can see both lines are fully overlapping with little gap. So we can say XGBoost predictions are accurate. Now close the graph and click on predict burnt calorie to enter exercise duration and get the calorie burn. So here I am entering 29 minutes and click on OK. So here we can see duration of exercise is 29 minutes and burnt calorie is 197.30. So in this way we can enter the duration of exercise and we'll get the calorie burn. So I'm entering here 40 minutes and click on OK. So here we can see duration of exercise is 40 minutes and we got the predicted burnt calories as 206.89. Now click on predict age and BMI from image to upload the image and get the predicted age. So I'm selecting the first image, open. So here we can see this is the image, and on top of the image we can see the BMI based on facial expressions is 23.48 and we got the predicted age as 31. Now close the image and let us select one more image. I'm selecting the 8th image and open. So here we can see predicted BMI based on facial expressions is 26.87 and predicted age is 46. Now close the image. Click on predict age and BMI from webcam. So the webcam will be on and it will predict the age. So here we can see we got the predicted BMI based on facial expressions and predicted age as 21, 22. It is continuously changing. Now close the image. And close the GUI, and the conclusion of the project is: through the examination of facial features, the project uses convolutional neural network CNN to estimate body mass index BMI. The CNN extracts important facial characteristics from the input facial photos and uses them to forecast BMI values. The modules include face and BMI detection algorithm execution, image uploading and loading BMI detection models. Users can upload photos and the system uses the derived data to predict BMIs and offer insurance plans. The experiment demonstrates the potential of CNN in linking face features to health parameters and presents a novel method for calculating BMI and recommending insurance plans, which may have an impact on personalized health assessment and insurance advice. Thank you for watching the video.
For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.